Eh. Now the symbols, we are going to write the symbols. Write the symbols. So I'm having it silver and then what? Gold. I want to remove this. Yes. You are finished? Potassium. What is the symbol for potassium? K. This is Na. Ca. I want to remove this. Allow me to create a space here. We have our potassium, sodium, calcium, magnesium, aluminium, zinc, iron. I'm having lead here, hydrogen. What else? Copper, mercury, silver, and gold. I want to fix carbon somewhere around here, in between aluminium and zinc. Let us put carbon. Now this is the order: most reactive. Are you together? Then this is the least reactive. That is the order of reactivity. How elements are arranged according to their reactivity, from the most reactive to the least reactive. Are you there? Are we done with looking this? Yes. Yeah, we need to be fast. From the most reactive to the least reactive, the arrow continues.
Don't you pay more for those reactive?
Now, I want to remove all this. Now let us bring our question. We are having copper oxide with the carbon. Are you there? Copper oxide with what? We have seen carbon is somewhere in our reactivity cell, and the copper is somewhere down. Hey, carbon is. Hey, yeah, I need to give you the phrase. It is okay, but just need to master it. It is in between there. Okay, we have said it. Carbon is somewhere, and then carbon is somewhere, and then the copper is somewhere. Between the carbon and the copper, which one is more reactive according to our reactivity cell? I'm saying according to reactivity cell on carbon and the copper, which one is more reactive? Carbon. So carbon is more reactive, and this one is less reactive. Now, look at this. Look at this. Are you together? Are you together? Now, if I get a substance, for example, copper oxide, and I mix it with another substance, which is the carbon, and this carbon is less reactive. You mix them and then you do what? and then you heat. I've got copper oxide and then the carbon. I've mixed them together. But I've seen copper is less reactive and the carbon is more reactive. What happens? A more reactive element comes and removes oxygen from this one, which is less reactive. If I get this substance and I mix it with another sub-element which is more reactive, the one which is more reactive comes and removes oxygen from another one, which one is less reactive. So what we are going to have here, you are going to find that this one, I'll be just getting the copper, and then this one takes up the oxygen. I have my carbon dioxide. Now I bring a question like this. I say carbon was heated with the copper oxide. State what was observed. Now observation. Now this, to give an observation, you have to be knowing the color of these things. Copper oxide is black. Are we together? This one is also black. Carbon is black. What is the color of copper?
Brown.
Brown. The question is, state what is observed when the carbon is heated with the copper oxide. Who can give me an observation based on the colors we have here? What can be your observation? Copper oxide was heated with the carbon. State what was observed. The brown color, Give me the color before and after.
Reaction here, man, you say Mrs. Demirun.
State what is observed when the carbon is heated with the copper oxide. The observation will be the black solid will turn to browny. Basing on the test, if the question was state what was observed, I will say black solid turned to brown solid. That's what you will see. Are you there? Then a reasoning for our observation. Who can give me the reason?
Yes, you people, I am wondering what kind of food you eat. We talked about reduction in reactions. Yeah? And I gave you that reaction when you are reacting copper oxide with the carbon. I gave it to you when you are reacting it with the hydrogen. The same reaction. Yeah? And also when you are reacting it with ammonia. Those are all reduction reactions. And the color changes are the same from black to brown. Naye musomesa abuuza, you are keeping quiet, mulinga abatagirabangako, kwegamba oba musoma biki? Omusomesa nabwe emphasizing ekintu, n'okutaako emphasis. Omuntu ayinza kutegeera nti bakitaddeko emphasis yennyina okutaako ki? Omulamwa. Why?
Okay. So excuse me, when you are giving an observation here, look what, like you need to give us what was the color before and then after. Are you together? So, observation, we shall be seeing a black solid turning to browny solid. I want it a reason.
The reason is because copper oxide was reduced to
So because copper oxide was reduced to copper. Someone else?
Because copper oxide, which is otherwise reduced by carbon.
Okay. So anyway, so the point is reducing. Yeah? So carbon is more reactive than what? Than copper. So it reduces it to what? To copper, which is brown. So that is it. So now let us come up with a question. We say reducing actually, then reducing agent. I write for me a question. And the question is saying, state what was observed, state what was observed when the following oxides were heated with the carbon. States what was observed when the following oxides were heated with the carbon. Part A, copper oxide. Part B, tri-iron tetra oxide. Tri-iron tetra oxide. Then another one, iron 3 oxide. Then part D, magnesium oxide. I want us to talk about this then. Right then? I said copper oxide, tri-iron tetra oxide, iron 3 oxide, and then magnesium oxide. Part B, give a reason in each case and write the equation for the reaction. Give a reason in each case and write the equation for the reaction. Give a reason in each case and write the equation for the reaction. And write the equation for the reaction. Are we done with that? Give a reason in each case and write the equation for the reaction. Can we start? I want us to start. We are starting, eh?
Yes.
Back benchers. Yeah, I'm finishing. Members. The first one is copper oxide, eh? Now I told you before giving an observation, you can work the equation somewhere so that you know which one is reacting with which and what is the product. So we have our copper oxide reacting with what? With the carbon, and we are getting the copper plus what? Carbon dioxide. So if I know the color of this one and this one, we said our observation will be what? What is our observation? We have said black solid turned to browny solid. And the reason is, let us give the reason immediately. So we can just say carbon is more reactive. Carbon is more reactive than copper. hence reduces its oxide, reduces its oxide to copper, which is brown. Or you can simply say carbon reduces copper oxide to copper. Give a reason for your answer. I can simply say carbon reduces copper oxide to copper. Your observation is black solid turned to brown solid. Usually carbon reduces copper oxide to copper. You can also get a mark for that. Are we there? Now the thing, we know about it. Hey, that is very good. We say the copper. Now there it is not just copper as an element. It was a compound containing copper ions. But the copper as an element, it is brown. But the compounds of copper, they are not brown. So it is like you can have blue or green. Yeah. Okay, I want to remove this. I've said the reason I can just say carbon reduces the copper to oxide to copper. You can bring it like that. Like I have said, carbon is more reactive than copper, hence reduces its oxide to copper, which is brown. Let us move on to another thing. Can we move on? Yes. So let us go to the equation. Our equation is copper to oxide with the carbon giving us what? Copper plus carbon dioxide gas. Can we check whether it is balancing? Is it balancing? Can we check together? Copper, how many? 1. This one is what?
1.
Oxygen 1 here. These are how many? 2. So we need to put a 2 here. When I put a 2, copper is affected. Here, this is the 1. These are 2. We also put a 2 there. And it's balancing. Yes?